Good morning, my dear students. In this video, I will discuss about earthquake resistant structures. This is in Mumbai University, Theory of Structure 7 for architecture students, B Arch students. Let us first discuss about the different terminologies that are used in earthquake engineering. Number 1, DBE, Design Basis Earthquake. इसका मतलब ऐसे है द अर्थक्वेक व्हिच कैन बी एक्सपेक्टेड टू ऑकर एट लीस्ट वंस ड्यूरिंग द डिजाइन लाइफ ऑफ द स्ट्रक्चर एंड दिस इज डिफाइंड बाय 1890 IS 1893-2002. So this is called the design basis earthquake. Next is the epicenter. Epicenter, what is epicenter? It is the geographical point on the surface of the earth vertically above the focus of the earthquake. Now what is focus or hypocenter? It is the source of the elastic waves of the originating earthquake inside the earth which cause shaking of the ground. In few minutes we will learn about the different elastic waves which will be generated in the earthquake. So focus is that point, the source of the elastic wave which originates from where the earthquake is originating, and epicenter is the point above the focus of the it is located just above the focus. Next is the intensity. What do you mean by the intensity of an earthquake? Intensity of an earthquake means that it indicates the strength of shaking during the earthquake or the amount of energy releases. In these two terms, it can be defined. That means the amount of energy releases, that is also called the intensity of an earthquake, or the strength of shaking during the earthquake, that is also called the intensity of the earthquake. Now what is magnitude? Magnitude of the earthquake, it is actually measured in Richter's scale. So this is also called the Richter's magnitude. It is expressed by a number which is a measure of the energy released in an earthquake. Next is what is seismograph. Seismograph, this is an instrument where the earthquake generated waves are recorded. Next is MCE. Full form is Maximum Considered Earthquake. It is the most severe earthquake whose effects are considered while designing by the IS Code 1893 Part 1 2002 edition. Next is the liquefaction. Here I just want to tell you that this question, liquefaction, this has also been asked as a question in GATE architecture. You can also see my GATE videos for the architecture subjects. So there you can see that one year this question has come, that what is liquefaction. So let us understand it. It is the state in a saturated cohesionless soil where the effective shear strength is reduced to negligible value. That means it becomes almost zero for all engineering purposes. But why this happens, liquefaction? This is due to the poor pressure caused by the vibrations during an earthquake when they approach the total confining pressure. In this condition, the soil tends to behave like a fluid mass. Okay. Next is seismology. What is seismology? Seismology, it is the study of the earthquake. Let us now discuss about the seismic waves. Seismic waves are what? They are the elastic waves which are generated at the focus when an earthquake happens. Now there are three types. Number 1 P, number 2 S, and number 3 L. So what are P waves? P stands for the primary waves. They are the fastest and the longitudinal in nature. Longitudinal means according throughout the axis of that, along the axis. So that is called the longitudinal in nature. S waves stand for secondary waves. Secondary waves means they are transverse in nature. That means which are perpendicular to the longitudinal axis, so that they are called the transverse nature. Third one is the L waves. L stands for the longitudinal waves. They are sluggish in nature. They are also called the surface wave. Why? Because these L waves, longitudinal waves, are mainly found near the surface layer. And they are also recorded after the P and S waves. That means after the primary and the secondary waves are recorded, longitudinal waves are recorded. Let us now see that what are the IS codes are there for the earthquake resistant structure design. So IS code for the earthquake design are as follows. First, the most important one is the IS 1893-2002. Now this has 5 parts. Part 1 में क्या है? Part 1 में this is the IS criteria for the earthquake resistant design of structure. Part 2, it is for the liquid retaining tanks, elevated and ground supported. Part 3, it specifies about the bridges and the retaining walls. Part 4, they are for the industrial structures including stack-like structures. Part 5, dams and embankments. Now here I just want to specify one more important point, that according to this IS code 1893-2000, India is divided into 5 zones, that is 1, 2, 3, 4, 5. They are denoted like that, 1, 2, 3, 4, 5. Now seismic severity increases with the zone number. That means if we go from, if we are talking about zone 4 and zone 5, that means the seismic severity is the highest or the most. Okay, so for example, Kutch, Maharashtra and Andaman, they falls under the zone 4 and zone 5. The second IS code is IS 4326 1993. See, after the colon whatever is written, that is the year number that has been edited. So the latest edition we are talking about. So 4326 1993, they are the IS code of practice for earthquake resistant design and the construction of buildings. Next is IS 13827 1993. This is the IS guidelines for improving earthquake resistance of earthen buildings. Next is IS 13828 1993. They are the IS code for improving earthquake resistance of low strength masonry building. Next is IS 13920 1993. These are the IS code for the, this is the IS code for the ductile detailing of reinforced concrete structure subjected to seismic forces. And the last one is the IS 13935. This is the IS guideline for the repair and seismic strengthening of building. Let us now discuss that what are the effects of an earthquake. So there are 2 types of effect in an earthquake. One is direct effect, one is indirect effect. Let us start with the direct seismic effect first. Number 1, surface faulting totally demolishes the houses, rupture the foundations, tilt the foundation slab, and they cause minor damage to the house. This is the first effect. Second one is the liquefaction of soil. As I have just explained few minutes before, that the liquefaction of the soil cause instability due to internal seismic wave, and they also cause the damage in the form of settlement, tilting and rupture of the structure. There may be either large settlement or differential settlement of the ground surface. Third effect, damage due to sliding of superstructure on its foundation if superstructures are not anchored properly to the foundation. Fourth is the damage due to structural vibration. We know that inertia forces are developed as vibration response of a structure due to earthquake. The intensity of the inertia force is directly proportional to the product of mass and acceleration. Hence, mass should be reduced to minimize the inertia force. Let me explain this point further, that as you know that what is inertia force? Inertia force is I, that is equal to m into a. This concept we get it from the Newton's second law, correct? So due to the earthquake, that as a response, vibration response, these inertia forces are developed. So inertia forces, we have to take care of this intensity of the forces. How we can take care? That as it is I is equal to m into a, so mass should be reduced. If the mass is reduced, the inertia forces should also be reduced, correct? So that will cause less damage to the structure. So let us see that how we can do it. So now we will discuss about the different materials or the role of the material used in the structure, earthquake resistant structure. Now see, In role of the material, we can say that the timber, reinforced concrete and steel, they are the mostly used material in the structure. The necessary requirement for a good design, earthquake resistant design, is that you should place the ductile materials at the points of the tensile stress in the structural components such as beams and walls, so that overall structural deformability and instability can be avoided. Ductile materials are designed for to take the tensile stress, so they should be placed in a proper place while designing. Positioning is very important. Positioning or the placing of the ductile materials. Next is the timber. Timber has the maximum advantage as the construction material. Why? Because of its low mass. फिर concrete. Then what is concrete? Concrete, it is a heavy material, okay, but when it is reinforced with the steel bar, steel is what? Steel is a ductile material. So concrete, while it is reinforced with the steel bar, we get RCC, reinforced concrete structure, correct? So it has the good strength both in compression and in tension. How? Because concrete is steel is good in tension, correct? Now accordingly, reinforced concrete can be used effectively by providing proper amount of reinforcement and correct detailing of them, as they play significant roles in seismic resistant design of reinforced concrete structure. Steel, as I have already told, that it has the additional advantages of ductility, strength and toughness per unit weight than concrete. Now, till now we have discussed about the direct seismic effect. Now, what are the indirect seismic effect? We all know that the indirect effects, under the indirect effect, it comes the tsunami, landslide, floods, fires. They are all the indirect effects of the earthquake. But they may either occur alone or they can occur in combinations. Let us see what are the assumptions in the earthquake resistant design of structure. Number one, impulsive ground motions of earthquake. They are very complex and irregular. They also change in period and time and of very short duration. So sometimes they may not cause any resonance except in tall structures on deep soft soil. This is the first assumption. Second assumption is that we consider that while the earthquake is taking place, simultaneously there is no wind force, there is no maximum flood or maximum sea wave occurring. Number three, for static analysis, we will see just after few minutes or in my next video, the static analysis and the dynamic analysis. There we will see in detail. So for static analysis, elastic modulus of the material shall be taken unless otherwise mentioned. So these are the assumptions for the earthquake resistant design of structure. Let us look at the planning stages of the seismic design. To achieve the seismic resistance at economical cost, three parameters are considered. Number one, seismic intensity zone, where the building is located. Number two, how important the buildings are. For example, important building that comes hospital, clinic, communication buildings, fire and police stations, then water supply facility, cinemas, theaters, meeting halls, schools, dormitories, cultural treasures such as museum, monument, temples. This comes under the category of important building. And number three criteria, third parameter is the how steep is the foundation soil. Now, steep soil means what? The steep soils means the SBC should be greater than 10 ton per meter square. SBC means safe bearing capacity of the soil. So the buildings can be constructed on firm soil and soft soil. Soft soil means the safe bearing capacity SBC is less than equal to 10 ton per meter square. But if we build the structure on the soft soil, it will be dangerous to build on the weak soil, because weak soil, they are liable to large differential settlement, liquefaction during an earthquake. Let us look at the different points or different aspects in the planning. Number one, Plan the structure in a symmetrical way both in plan and elevation. And also the doors and the window openings should be placed, and their size should also be symmetrical, because if it is asymmetry, it leads to the torsion during the earthquake. So first point is the structure भी symmetrical होना चाहिए, doors and windows के size भी symmetrical होना चाहिए, their placing should also be symmetrical. This is the first point, because asymmetry leads to torsion while earthquake occur. Second point, choice of site. While choosing the site of the structure, we should be very careful from the seismic point of view with respect to the stability of the ground. Remember that the hillside slopes, they are liable to slide during an earthquake, so it should be avoided, and we should see only, or we should consider only the stable slope for the construction. Point number 3, avoid open ground which is used for car parking. Point number 4, avoid thinner slab and flat slab. Point number 5, provide openings for the doors and the windows at a distance of minimum 0.6 meter from the column edges. Point number 6, parapets of the buildings must be reinforced and held to the main structural slabs or frames. Point number 7, location of water tank and the swimming pools should be done strictly according to the IS code, because they create a vast difference in the center of mass while you are creating a water body, correct? Point number 8, provide plinth beam at the ground level, lintel and the roof band. Point number 9, avoid lowering the beams in RCC frames at the lintel level. Point number 10, restrict the length of the block to 3 times its width, as torsional effects of the ground motion are pronounced in long, narrow, rectangular blocks. So avoid designing long, narrow, rectangular block. So, but if it is required that longer lengths are required, then 2 separate blocks can be created with sufficient separation in between them. A large building should be separated into several blocks to obtain symmetry and regularity of each block. It also prevents hammering or pounding damage between the blocks. Point number 12. Ornamentation involving large cornices, vertical or horizontal cantilever projections, they are dangerous and undesirable from a seismic viewpoint. So please keep it in mind. When ornamentation is insisted upon, that means you have to provide from the architectural point of view, it must be reinforced with steel. If designed, a seismic coefficient about 5 times the coefficient used for designing the main structure should be used for cantilever ornamentation. Point number 13. The building should be constructed of fire resistant materials. Why? Because it is not unusual during the earthquake that due to the snapping of the electrical fittings, short circuiting takes place, or gas pipes may develop leaks and catch fire. Fire could also be started due to the kerosene lamps or the kitchen fires also. So while designing the building, you should consider also the fire resistant materials. Let us now see about the soil and the foundation aspect for the earthquake resistant structure. In farm soil condition, as I have discussed in my previous video also, that any type of footing, isolated or strip type, can be used. It should have a firm base of lime or cement concrete with requisite width over which the construction of the footing may start. Isolated footing should be connected by means of RC beams just below the plinth level, intersecting at right angles at 90 degree. Okay. In soft soil, isolated footings are connected by means of plinth beams. But continuous beams are the most effective from the earthquake consideration, because it avoids differential settlement under normal vertical loads. Continuous footing should be reinforced both in the top and the bottom faces. Width of the footing should make the contact pressures uniform. The depth of the footing should be below the lowest level of weathering. Very loose sands or sensitive clay, they are also liable to be destroyed by the earthquake, and they actually lose their original structure, and that results in large unequal settlement and damage the building. So you have to take care that which type of soil that area of the site is having. If the loose cohesionless soils are saturated with water, they will lose their shear resistance during shaking and become liquefied. So these soil, they can be compacted, we agree, but for small buildings the operation may be too costly and these soils are better avoided. Correct? Drainage condition of a site must be improved so that there is no water accumulation and it should not saturate the ground close to the footing level. Let us now discuss about the design philosophy of the earthquake resistant structure. First of all, the structure should possess minimum strength and ductility to withstand minor earthquake which occur frequently without damage. Number 2, structure should possess minimum strength and ductility to withstand moderate earthquake without significant structural damage, though some non-structural damage may occur. Number 3, structure should possess minimum strength and ductility to withstand major earthquakes without collapse. Point number 4, the interconnections of the members must be designed to ensure sufficient ductility. How you can do it? Number 1, by decreasing the percentage of the tension steel or by increasing the percentage of the compression steel. Number 2, by increasing the compressive strength of concrete. Number 3, by increasing in the transverse shear reinforcement. The forces of an earthquake can be safely diverted through the primary load paths, for example with the horizontal load path and with the vertical load path. Under horizontal load path, number 1 is tuned liquid dampeners, which is known as TLD. Number 2, self-righting buildings. Number 3, tuned mass dampeners, TMD. And number 4 is the very important one, that is the base isolation. I will elaborate this point about the base isolation. What is base isolation? What happens over here? To avoid the high amplitude and the high frequency motion and the forces which are developed during the earthquake, the structure is isolated from the ground motion. How? By placing a flexible connection or by placing 2 layers of good quality plastic between the structure and the foundation. Sometimes a house is also built on short post resting on large stone. So when the earthquake happens and the motions occur, so at that time the posts are effectively pin connected at the top and bottom, and the structure can move to and fro and they can reduce the lateral forces. So the structure can be saved also in this way. And under the vertical load path, so it comes that the providing the shear walls, providing the tubular design, and by providing the bracing in walls also, the forces of the earthquake can be diverted. Now finally, let us discuss about the design approach of the earthquake resistant structure. There are 2 methods. Number 1, static elastic design method, and the second is the dynamic design method. In the static elastic design method, this is considered for the smaller building, this design method. So let us look at the points. Number 1, dead loads and the imposed load or the live loads, they are considered. Number 2, horizontal or the lateral loads are also determined. Number 3, bending moments and shear forces are determined on columns and floor beams in a manner similar to that of frames subjected to wind loads. Number 4, all parts must be efficiently bonded together so that the structure acts as a unit. Number 5, panel walls, finishes and ornaments, they should be permanently attached to the frame to ensure that they do not collapse independently in the event of a shock. Number 6, separate footings of columns shall be connected by ties to resist the compressive or tensile thrust of magnitude 1/10th of the load on the footing. At the end, let us look at the dynamic analysis method. This is carried out either by time history method or by response spectrum method. Dynamic analysis is performed to determine the seismic force and the distribution to different levels for number one, for regular buildings. Regular buildings means those which is greater than 40 meter in height in zone 4 and 5, and those greater than 90 meter in height in zone 2 and 3. Second case is in case of a irregular building. Irregular building means all framed buildings higher than the 12 meter in zone 4 and 5 and higher than 40 meter in zone 2 and 3. In this video, I have tried to explain whatever is needed for the 7th semester architecture students under Mumbai University. Any topic, if you want to learn more on this any topic, read any or refer any standard notebook for further reference. You can leave your comment in the comment box, and also you can ask me any query in the comment box, or you can mail me at the given email address. Thanks for watching.